I'm Molarity. You've seen me in such fine quality, epic chemistry educational videos as... Does molarity have a connection with the molars in my mouth? And molarity and concentration, the connections. In the last video, we talked about what was the idea behind molarity, that it's the concentration. We talked about what would that look like using the example of soda at a fast food place. Now we're going to be looking at some molarity problems. If you don't get the idea about molarity, or you don't know what I'm talking about, go check out that previous video. Okay? I'm here just to go ahead and break down molarity problems. Okay? Now, in real life, you have things like making salt solution. Okay? Medical supply companies need to manufacture that, and they're going to need certain concentrations of salt solution that they put in the IV bags that they can actually ship that out to hospitals and, be able to, I don't know, do things like save lives! Maybe. Just thinking. Okay? So we have our basic formula here about molarities equals moles per liter. So we have a question. Okay, and I need 1 liter of 0.15 molar of salt. Okay, so I got 1 liter of 0.15 molar of salt. Okay, how do I prepare that? Well, when they say how do you prepare it, that means how many grams of salt do I need to add to this 1 liter in order to actually make the solution? Okay, well, what do I know? I know NaCl. I know that Na, according to our periodic chart, is about 23 grams per mole, okay, roughly. Chlorine is about 35.45 grams per mole. So we know that 1 mole of NaCl will be about 58.45 grams per mole. Okay? So that's what it's going to look like. All right. Now, we got that. And you say, well, why in the world are you preparing this? Let's look at our formula here. If we look at the formula, molarity, which is always represented by the capital N, notice how I did that over there, okay, is equal to moles over liters. Now in this case, they gave me my liters, right? And they gave me the molarity. So I'm going to have 0.15 molar equals X moles over 1 liter, because that's what they gave us. Okay? So now, how do we go about solving this? We need to solve the number of moles. How many of these salt crystals do we actually need? How many of these salt molecules do we need? And that's where the moles comes in. If you don't know what moles are, check out my other videos. Okay? So here, there's 2 ways we can do this. We can go ahead and multiply 1 liter times 0.15 molar. So let's go ahead and let's do that. Remember that molar is moles over liter. It doesn't matter if it's mole or moles or liter or liters. Whether the word is plural or singular, it doesn't matter. It's still the same unit that you're looking at. So let's rewrite this for a moment. 0.15 moles per liter, and we're going to multiply that by our 1 liter, and that's going to equal 0.15 moles. Well, wait a minute, what happened to the liters? Well, remember, if you look at this, how the molar thing here, it translates into moles over liters. And you're multiplying by liters, so the liters will actually cancel out. So now you're left with moles. And there you go. You're good to go. Now that's one way to look at it. There is another way to do this. So let me go ahead and I will write this up again. 0.15 molar is equal to X moles over 1 liter. That's what they gave us. There's another way to do this, and that is you can use proportion. in math, you can get away with putting this over 1. Well, wait a minute. Why can you do that? Well, remember, anything over 1 is anything. Oranges over 1 is oranges. Okay? 0.15 molar is over 1 is 0.15 molar. So we can go ahead and do that. We can get away with that. We have the power to do that. And then we can go ahead and do the cross, multiply, divide. Right, the proportion. Cross, multiply, and divide. So, what does that look like? Well, we're going to have x times 1. Notice with the green arrow here that I'm doing this in green so you see where it's being multiplied. And we're going to find that it's going to be equal to, because remember this is a proportion, 0.15 molar times 1 liter. Now notice how I did this in red, which matches the red arrow here, okay? So we go and look at that, and we can say, all right, x is equal to 0.15 moles. You'd say, wait a minute. Whoa. You went from molar to moles. So remember, molar is moles over liters, and you're multiplying that by liters. The liters cancel out. That's how I know that I'm going to end up with moles. Great. Fantastic. So you took that molar unit, you multiplied it by liters, you're left with moles. Right, that's what you're supposed to be left with. Okay, what about here? So we're left now with 0.15 moles. Now, is that our final answer? No. How come? Come on, guys. Are you going to go send somebody out there and say, okay, Joey, go and count out 0.15 moles worth of salt crystals? That's going to be very difficult to do. That's going to be a real pain. So, what do we need to do? There is something we can do. We can change the moles to grams, because remember, I've got the number of salt molecules. Now I need to know how much does that weigh. And that's how we operate. It's like, again, having, great, I've got 15 slices of ham. How much does this ham weigh? It's the same analogy. Again, that's where the stoichiometry comes in. So we're going to have to go from moles to grams. Well, if we're going from moles to grams, we're going to need to multiply. Now, I can show you that triangle, again, here, okay, like this, where we have grams, grams over moles, and moles. And since I'm interested in finding the grams, I can turn around and say, okay, this is what I want to find out. So that is what I need to find out. That's why I'm blocking it, because I don't know what this is. This is what I have to find out. And what am I left with? Well, I'm left with moles, and I'm left with grams per mole. Ooh, hey, what's going on here? Well, we can actually multiply those out, because notice how they're right next to each other. It's like saying, let's multiply them. Great. So we have 0.15 moles multiplied by, oh wait, how many grams are there in a mole of salt? Well, we went up here earlier and we figured out 58.45 looking at these on the periodic table. So we're going to go back here, 58.45 grams per mole. Okay. And that's what we have. So let's go ahead, let's just quickly multiply this out. 0.15 times 58.45 equals, and we have, rounding to 2 decimal places, 8.77 grams of salt that we're going to need. So we would need to add about almost 8.8 grams of salt to this 1 liter of water to get this 1 liter of salt solution with the concentration of 0.15 molar. Okay? Well, that's it for this particular video. I'm just trying to break it down a little bit into shorter segments here. So we went over one example of a molar problem we can go ahead and work on another example of a molar problem where we're now working with less than 1 liter. Okay, I hope this video helped you guys out. If you need to continue on, well, there'll be some others. All right, take care. This is Molarity signing off.